So we have seen that these 5 commands, this sequence of 5 commands has been documented, has been animated in form of an object diagram and in form of 3 state machines that are attached to the 3 objects over here. And the explicitly constructed objects are the 2 profile objects, and the invite operation here is responsible for constructing the friendship object. This was the first way to show this animation. As we see it here, we have used the state chart together with an object diagram and the use command list. The second option in order to animate and document this very simple scenario, just 2 profile objects and just one invite, just one friendship process going on. The second option here is to describe it with sequence diagrams. And we will see in this animation documentation with the sequence diagram, we will see here the command list. Again, we see here the first command, and in total we will see the 5 commands that we have seen previously in connection with the state chart and the object diagram. The sequence diagram over here now indicates that we have created 2 objects, 2 profile objects, the Merkel and the Putin object. The second command now indicates that on the Merkel object the initialization, the init operation is going on and has been issued. The third command in the command list is that this init operation is issued in the Putin command as well with the appropriate parameters here. The invite command, which is issued by Putin with the parameter Merkel. We see it over here, and we see now nicely in the sequence diagram the connection between this invite operation call and the creation of the friendship object. This connection, we have not seen it before so directly. We saw it in a transition, but we saw it not directly in one of the diagrams. Namely, the invite operation, inside the implementation of the invite there is a create going on, and it's a create friendship between Putin and Merkel. And we see here that's more or less a use specific indication. We see here messages which, so this message goes from the lifeline of Putin because he is the one on which the invite is called. This create is, so to speak, done by the creation of the friendship object is initiated by Putin, and therefore this message this create message is indicated here in the part of the lifeline where some activation or where the object is active. And we see that here, as analogously to the creation of the profile objects, here a friendship object is created, and then this friendship object informs, so to speak, the Putin that he is now the inviter in this friendship, and this friendship object also informs Merkel that the Merkel object is the invitee, the one who has been invited. That was the fourth. Operation call. The fifth operation call is now that Merkel. We see it here on the lifeline of Merkel. Merkel accepts the friendship request by Putin, and this again in the implementation of the accept operation. There is an accept F going on. The accept F is the accept operation in the friendship class. So this is the accept operation in the profile class, and the accept F operation is the accept F operation in the friendship class. We can jump to the class diagram to see it. So we have an accept in the profile class, and we have an accept F in the friendship class, and symmetrically to this case we have a decline in the profile class and a decline F in the friendship class. And by the way, we have these accept F and this decline F. We have both of them in the state machines for the friendship. But I was talking about the sequence diagram. So this is the accept F, which is done in the implementation of the accept F in the friendship class, is called in the implementation of the accept operation in the profile class. And yeah, this completes the animation, the documentation here of the sequence diagram. Two further hints. Hint number one: you can tune the sequence diagram to show the states from the state machines. So we could have shown here the born state and the living state here, and we could have shown here the what was it on the friendship. We could have shown the pending and the accepted. So we could have shown, I could have shown here the pending state and the accept state here. That was remark number one. So there is a combination. You can display in the sequence diagram part of the state chart diagram. So this is sort of a combination then of the sequence diagram with the state chart diagram. And the second remark is I have only shown here these commands, the operation calls. We could have shown also, and I have done so in the previous sequence diagrams, we could have seen here also the assignments of the attribute value. So inside this init, for example, the attributes first, the attributes of the profile attributes, first name, last name, username are manipulated here, and we could have seen these details also here by tuning the sequence diagram in a particular way. I have decided here to give a rough overview and not to show. I've decided not to show the what is going on inside the single operations here. Okay, I think yeah, that's what I wanted to say about this sequence diagram. So that was a second option to show, to animate this dynamic behavior in form of the sequence diagram. We have handled the sequence diagram. Now let's come to the communication diagram. The communication diagram, let's jump a bit ahead. The communication diagram also shows dynamic behavior, but it looks the difference between the sequence diagram and the communication diagram is that in the communication diagram the messages are ordered here with a numbering system. So in the communication diagram we see here message 1, message 2, 3, 4, 5, 6. This message ordering is done in the sequence diagram in a geometrical way. Yeah, we have here create, init, invite, accept. So exactly these 6 messages, create, init, invite, accept, that these 6 messages that are ordered here geometrically are indicated here with a numbering system. Create, init, invite, and the accept over here. But let's go into the details here. So the communication diagram looks more like sort of an object diagram with associations with links between the objects. This actor here in the communication diagram corresponds to the actor that we have here in the sequence diagram. So you can think of this actor as a use shell. And the use shell is present in the sequence diagram, and the use shell is present in the use shell is present also in the communication diagram. So we have here the creation of 2 new objects, the Merkel object and the Putin object, and we see now that the actor has issued first the create for the Merkel, and as in the second position, first Merkel, then Putin, and in the second position the object Putin was created. Then we have the init on the Merkel object, and we see here that this init operation is issued in total as the 3rd operation call in the total sequence with parameters Angela Merkel Mutti as username. And now I have decided here to show the details of what is going on in the init here, and there you see it is sort of that Merkel is changing the object Merkel is changing his own attributes, and you see that the attributes are assigned some values that come here as parameters from the init operation. And these are all messages. So the message number 3 is the message number 3. That's it's here numbered in. It's numbered here by 2 because the creates are numbered differently. So this init is exactly this init which is issued on the shell and which is targeted towards Merkel, and therefore this arrow targets from the shell, from the actor to Merkel. And but the details, the assignment here are sort of messages which are sent from Merkel to Merkel, and this is indicated here with this sort of loop for the assignments of the attributes. That's a convention in the communication diagram. Analogously, we have the initialization of the Putin object with a respective parameter. Then we see here the next operation call is the invite, and that's the creation of the friendship object which we have also been looking at in the sequence diagram. So the friendship, the invite is issued on the shell from the actor towards the Putin, and inside the implementation of the invite now creates as a sub-message. 5 is the invite and 5.1 is a sub-message. That's the creation with an insert Putin Merkel, because friendship here is viewed as a link. In the sequence diagram, it is more viewed as an object. Here is more viewed and displayed as a link. Both views are acceptable because friendship is a link object. It is a hybrid between an object and a link. It is both an object and a link. So you can view friendship 1 as a link, which is done here, and you can view friendship 1 as an object. The sequence diagram does not display the object identity. So that was the creation of the link. And then, one additional remark that I wanted to make. So the numbering system is in the communication diagram is such that message number 5 has sub-messages, and this 5.1 is a sub-message of 5. And analogously, 3, the message number 3 has sub-messages 3.1, 3.2, 3.3. And these are exactly the messages that I was talking about. I did discuss this when I was looking at the sequence diagram, that I did not show here the details of the init, and this is exactly done here in the communication diagram. In the communication diagram, you also have means that you could hide these details here. You could only show the topmost messages. I have decided here to show the topmost messages and all sub-messages that are created by the topmost messages. So we see here these sub-messages. Yeah, and the last operation now is the last operation is now the acceptance of the friendship by Merkel, and this operation number 5 is something that goes again from the actor to the Merkel object, which we see over here, and this accept has a sub-message. Namely, it is an accept message which goes from Merkel to the friendship object, and that's the accept friendship operation, which is an operation in the friendship class. Accept is the operation in the profile class, accept F is the operation in the friendship class. And this then, the last message here sets the status to accepted. Okay, as a main message, you should take with you the communication diagram displays a dynamic behavior in form of objects and messages that are exchanged between the objects, and the order of messages in the communication diagram sits in the numbering system, where the ordering of messages in the sequence diagram sits in the geometrical arrangement here. And that's also one of the reasons that in UML you see much more use of sequence diagrams, because they have a sort of, in quotes, intuitive understanding, intuitive representation of the message order the message order is the message order in the communication diagram is not so visually not so directly accessible as it is in the sequence diagram. Okay, that was the communication diagram used for a simple dynamic behavior, for a simple dynamic scenario. Let's go for the last form of representing the dynamic behavior, namely let's go for representing it with OCL queries on the use shell. So just to give you an overview, what we will see, I will directly show you everything what is available in this scenario. The scenario documentation with queries is just a textual representation, and everything that is done here in the textual form you will find it on the use shell. And that's the main message here. The use shell can also be used for documenting the effect of a scenario by employing OCL queries. And this underlies again the importance of the OCL and how the OCL can be used as a language. On the use shell, I have issued here the first commands, create Merkel and Putin. Yeah, you know, this is what I'm going to do on the use shell is exactly these commands here that we have previously seen in the command list. So create Merkel, create Putin, and now what I do, I'm posing two queries. And the exclamation mark is the indication that some execution is done on the use shell that changes the state of the system, and the query is the question mark is the indication that we have an OCL query here. The query that I'm stating is as follow. I'm stating here two queries. And the first query that I'm stating here, I'm accessing all profiles, profile.all instances. Then I'm collecting. Something. That's a collect operation on a collection of objects here. I'm performing the collect operation. With the P, with the variable P, I'm iterating over all the elements here, over all the objects here. So with the P, I'm iterating over all the profiles. And what I'm now doing with the P is that I'm building a tuple. We have not seen tuples. I think we have seen tuples very shortly one time. And we will see them in detail more. But the message is very simple. In OCL and in UML, tuples are available. Tuples are things where you can have where you describe a structure of things. So a tuple here, this tuple here has two components. The first component is called PF and the second component is called UN. PF, I've chosen these two names, PF and UN, are names that I can choose spontaneously in OCL for the tuple components. So this tuple component PF stands for profile and UN stands for username. I couldn't, instead of writing here PF and UN, I could have written explicitly the longer names profile and username, for example. But I've decided here to have a short name, and with these names you access these are the means for accessing the components of the tuple. And now the values of the tuple, they in the first component is simply the P, that's a profile, and the second component is p.username. So I'm navigating, or I'm taking from the profile. It's a profile object, and then I'm taking the attribute value username. And after I have been issuing this command here, so there's a profile, there are two profile objects, Merkel and Putin, and then when I state this query, I will, this query expression will return a bag of tuples. Remember, the collect always returns a bag, never a set. And there are two tuples here. There are two profile objects, and so there are two tuples here. There's a Merkel tuple and there's a Putin tuple, and both their username, we have not initialized the objects. Yeah, the username, both usernames are equal to the empty string. And in a similar way, I'm doing on the shell a query over the query which iterates over all friendship objects. I'm iterating here over all friendship objects, friendship all instances, collect. F, with the F, I'm iterating over all friendship objects, and I'm doing quite similar thing that what I've been doing in the first part over here. I'm building the a tuple with two components. Fs is a friendship, and that's the F, and the status is the f.status. And there are no friendship objects currently available, and the result of this tuple is the empty bag. And the principle for the documentation here with OCL queries is, the principle is I'm going to issue here the commands, and then I'm issuing again these two OCL queries, and then I look at the results, and the results of the queries show how the system state has changed. So after the first init operation, we now see the first query here has a different result. So in the first the result of the first query said username is the empty string, and now we see username is equal to Mudi. Username of Putin is still the empty string. The result of the second query has not changed. When we perform the init operation on Putin, we see the username of Merkel has not changed, but the username of Putin has changed. And when we're doing now the invite, we do not see a change in the result of the first query, Mudi, crap, but now we see a result in the second query. When we have the invite, there is now suddenly a friendship object available. So the query here, friendship all instances, is not empty anymore, but there is a friendship object, and we are issuing here also the status of the friendship, and the status of the friendship is pending. Now when we have the last operation from our scenario, Merkel except Putin, again the result of the first query does not change, but the result of the second query changes. For the friendship 1 object, which is a friendship object, the status changes from pending to friendship. And so you see here that also with OCL on the query, on the use shell, you can trace the system development, the system changes here with queries. The queries that we have seen here, profile all instances, the collect on the profiles and the collect on the friendships, are just one way of querying and tracing the changes in the system state. There is another query that one could use to trace all the changes. and the query is a more complex query. Yeah, it's a collect over all friendships, and the tuple that is built here, the tuple has three components, namely the username of the inviter of the friendship and the username of the invitee of the friendship and the status of the friendship. And when you issue this query in the last state, you would get here crab is the username of the inviter, muddy is the username of the invitee, and the status of the friendship is accepted. The ter and the t refer here to the inviter and to the invitee. So these were these 1, 2, 3, 4 different ways of animating and documenting a simple scenario. You can do it in quite different ways, and use offers a quite wide range of options to document a dynamic scenario, a dynamic behavior in form of state charts, object diagrams, sequence diagrams, communication diagrams, and you can even do it in textual form on the use shell.